Welcome to our exploration of heat waves versus cold spells, the paradox of climate variability. In this video, we'll delve into the contrasting phenomena of heat waves and cold spells, examining their definitions and the reasons they occur. As climate change continues to reshape our environment, these temperature extremes are becoming increasingly prevalent, impacting our health, economy, and ecosystems. Join us as we uncover the complexities of these opposing forces, the science behind them, and the broader implications for our planet's future. 1. Understanding heat waves. A definition: heat waves are a phenomenon that many have experienced, especially during the summer months. These events are characterized by prolonged periods of excessively hot weather, which can last for several days or even weeks. What makes a heat wave particularly challenging is the combination of high temperatures and increased humidity, creating a stifling environment for those affected. The severity of a heat wave is not just about the temperature but also how it compares to the usual climate conditions of a specific area. For instance, a temperature that is considered normal in one region might be a heat wave in another. This localized definition means that the impact of a heat wave can vary greatly depending on where it occurs. 2. Defining cold spells. The icy counterpart. On the flip side of the temperature spectrum, we have cold spells, also known as cold waves. These are extended periods of unusually cold weather, often catching people by surprise, especially in regions not accustomed to such frigid temperatures. Like heat waves, cold spells are defined relative to the typical climate of a region, meaning what constitutes a cold spell in one area might be considered normal in another. The sudden drop in temperature can disrupt daily life, cause health issues, and strain infrastructure. The unpredictability of cold spells adds another layer of complexity when planning for weather-related challenges. 3. The impact of climate change on heat waves. Climate change is a pressing issue that has far-reaching implications, particularly when it comes to heat waves. As global temperatures continue to rise, the frequency, duration, and intensity of heat waves are also increasing. This trend is linked to the overall warming of the planet, making extreme heat events more common. The consequences of more frequent heat waves are significant, affecting everything from agriculture to public health. As temperatures soar, energy demand skyrockets, straining power grids and increasing the risk of blackouts. The rising occurrence of heat waves serves as a stark reminder of the urgent need to address climate change on a global scale. 4. Polar vortex. A cold spell contributor. Despite the warming global climate, cold spells continue to occur, often influenced by disruptions in the polar vortex. The polar vortex is a large area of low pressure and cold air surrounding the Earth's poles. When this vortex weakens or shifts, it can allow frigid Arctic air to move southward, leading to extreme cold in lower latitudes. This phenomenon explains why, even in a warming world, we can experience sudden and severe cold spells. The interaction between the polar vortex and regional weather patterns is complex, but it highlights the dynamic and sometimes paradoxical nature of climate variability. 5. Temperature extremes and their growing presence. Both heat waves and cold spells are examples of temperature extremes, which are becoming more pronounced due to climate variability. These extremes can have profound impacts on ecosystems, infrastructure, and human health. For instance, heat waves can lead to droughts, while cold spells can cause frost damage to crops. The increasing frequency of these extremes poses challenges for communities and governments worldwide, as they must adapt to more unpredictable and severe weather patterns. The ability to manage and mitigate the effects of temperature extremes is crucial for building resilient societies in the face of climate change. 6. Urban heat islands. Cities and heat waves. Urban areas are particularly susceptible to intense heat waves due to the urban heat island effect. This phenomenon occurs because cities, with their abundance of concrete and asphalt, absorb and retain heat more than surrounding rural areas. As a result, urban centers can be significantly warmer, exacerbating the impact of heat waves. The increased temperatures in cities can lead to higher energy consumption as residents rely more on air conditioning to stay cool. Additionally, The health risks associated with heat waves are magnified in urban environments, particularly for vulnerable populations such as the elderly and those with pre-existing health conditions. 7. Health impacts of temperature extremes. Both heat waves and cold spells pose significant health risks to affected populations. Heat waves can lead to heat-related illnesses such as heat stroke and dehydration, and can be deadly, especially for the elderly, children, and individuals with chronic health conditions. On the other hand, cold spells can result in hypothermia, frostbite, and the exacerbation of chronic health issues like cardiovascular and respiratory diseases. The health impacts of temperature extremes underscore the importance of preparedness and response strategies to protect vulnerable populations during such events. 8. Economic consequences of extreme weather. The economic impacts of heat waves and cold spells are substantial and multifaceted. During heat waves, there is increased energy demand for cooling, leading to higher electricity bills and potential strain on power grids. Agricultural sectors can suffer as crops wilt under excessive heat, leading to reduced yields and increased food prices. Similarly, cold spells can increase heating costs, damage infrastructure, and disrupt transportation systems. The economic burden of these events highlights the need for investment in infrastructure resilience and adaptive strategies to mitigate the financial impacts of climate variability. 9. Ecosystem disruptions. Nature's response. Extreme temperatures can have dire consequences for ecosystems, disrupting the delicate balance of nature. Heat waves can lead to droughts, wildfires, and loss of biodiversity as plants and animals struggle to survive in the harsh conditions. Cold spells can also affect ecosystems by disrupting the life cycles of plants and animals that are not adapted to sudden, extreme cold. These disruptions can have cascading effects, impacting food chains and ecosystem services that humans rely on. Understanding and mitigating the impacts of temperature extremes on ecosystems is crucial for preserving biodiversity and maintaining the health of our planet. 10. Climate variability versus climate change. The paradox of climate variability and climate change lies in the coexistence of rising global temperatures with localized cold spells. Climate variability refers to natural fluctuations in climate patterns, while climate change refers to long-term shifts in temperature and weather patterns due to human activities. The complexity of climate dynamics means that while the planet is warming overall, regional weather patterns can still lead to unexpected cold spells. This paradox highlights the need for a nuanced understanding of climate dynamics and the importance of addressing both climate change and variability in our efforts to build a sustainable future.